Well, hello again out there in remote learning land. Jumping into a new exciting topic, like we said, meteorology, right? The science of weather. Awesome stuff. So, anyways, hopefully you worked hard on the do now question. We're going to talk about methods of heat transfer today. How does heat flow? And of course, the big three ways I'm sure you've heard of, right? Conduction, convection, and radiation. We'll talk about the details of those and how that relates to what happens in the atmosphere and all that good stuff. Okay? I want to start out with a funny clip from a classic movie. Right, the late Robin Williams, a very funny comedian. Check this out. What I want you to look for, of course, is why does Miss Doubtfire get burned, and the three different types of heat transfer. See if you could point out an example of each type of transfer: conduction, convection, radiation. Here we go.
Let's see. Okay. Pitch your baseball. Ow! Damn! Oh my God, it's clotted. Oh God. This holiday smells like burnt rubber. God, it's hot in here. Look at this. My first day as a woman, I'm getting hot flashes.
So anyways, obviously touching something directly, right? That's conduction. That's direct burn. And then there's, of course, the steam coming out of the pots, convecting. Right? The circulation of fluid, of heat's moving in fluid. And then radiation, where it'll travel through light rays, like the feeling the heat from a fire when you're standing, 10 feet away from it. You can still feel the heat coming off. That's a radiation. So yeah, all three classic radiation heat transfers were in there. Okay. So here we go. There you have heat being applied to the bar, and it'll transfer down the bar by conduction, right? Those molecules are touching each other, okay? And they'll vibrate and rub against each other and transfer heat down that bar. We call that conduction. Make sure you get your definition down there. It works best in solids, right? Metals in particular. And I'm sure you have experienced that if you've ever done cooking and accidentally touched the pot after it's been on the stove for a while. All right, that was conduction that burned your finger there. Okay. This system here, you can see the bar that would transfer heat across by conduction. If some is lost to the air, that would of course be by convection. Okay. In this case, remember, heat goes from hot to cold, so it's going to flow from the 60 to the 20, from the source to the sink. Okay? In an open system, energy is lost to the air. But if this is totally sealed up, if these cups are sealed, if the bar is insulated, then it's considered a closed system. And every amount of energy that's lost from this cup would be gained in that cup. Okay? Okay, make sure you get this in your notes. All right. This kind of gives you an example of what's going on. You have a hot object and a cold object. Here they touch, and you can see the colors kind of bleed together. That's showing you energy transfer. So the red going into the blue, and of course turning it in the end kind of a purple. When you put those two together, you make a purple. And now they're both the same temperature. They have the same amount of heat energy. All right, that's a dynamic equilibrium. All right, then we go to this method here. If you're talking about a circular motion in fluids, you're talking about convection. This is the classic way that a room gets heated up, right? The hot air comes out of the radiator, rises, circles around, gets colder, more denser, sinks, goes back into the radiator, gets reheated, etc. That's what's going on in your pasta pot, right? When you're cooking, that's why your pasta's moving all over the place. You could really see it if you're doing those little macaronis, or if you had a glass pot. Convection, right? The transfer of heat by currents, right? The circular motion. And it works with liquids and gases. Not so much in solids, but with liquids and gases. The convection cell is what you're looking at here. This is tied to the theory of plate tectonics, where the reason we get earthquakes and volcanoes is because this heat from the center of the earth is rising, making the magma convect. And that, of course, would make the plates above it, the continental plates above it, move and shake, and that's why we get an earthquake. Okay? Here you have two different examples. So here your convection currents would be from the middle, kind of like that. But over here, they would just be one big convection current like that. Okay? You should be able to draw in the convection currents on those diagrams. Okay. And the final one, of course, radiation, the classic campfire scenario, where you feel the heat coming off, and it's not that it's convecting in the air. It literally transfers to you by a process called radiation, all right, electromagnetic waves. That's how the Earth gets heated by the sun, right? There's no air in space. There's no convection going on here. But those light waves travel through space, and the Earth absorbs that light by a process, we call it radiation, okay? Maybe you've been to a store where they're advertising one of these heaters, or if you go to a restaurant and on a cold day, they might have one of those heaters in the doorway when you go in. I know a lot of diners have them, and boom, you feel that heat right away, right? You're absorbing that heat by the process of radiation there. All right, so what you guys got to do, you got to look at these 6 pictures, and you have to label which type of energy transfer is on each one. Some might have more than one, so literally write right on it which type it is. Is it conduction, convection, or radiation? Okay? And then following this, there are, of course, a couple summary questions that you got to crank on as well. All right? We'll go through those back in the GC. So work hard on them. See you in a minute.